Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Let's begin this lecture. طبعا مثل ما حكينا last time, today's lecture will be included in the quiz that we're going to have on Sunday إن شاء الله. طبعا الكويز راح يكون on Sunday at 5 p.m. راح يكون on e-learning. Okay. فخلينا نبدأ بالأول بالlecture. Last lecture we talked about a new distribution for random variable, because we said we have in the previous lecture we talked about probability mass function PMF, but that was good enough for a discrete random variable. So we introduced a new random variable or a new distribution. It's called CDF, or cumulative distribution function. And that was good enough for both discrete and continuous random variables. And we talked about the properties for that distribution. We had a few examples on that. And today, we're going to introduce a new distribution. Okay, and it's called the probability density function, PDF. So the random variable can be described in either CDF or PDF. Okay, some people, they like to use the PDF because it's easier to deal with. So we don't really know, depending on what you have available. Okay, so basically, as you see, I have some notes for you along with the voice recording on e-learning. By the way, it's the same thing we're talking about here. On page 34 of the notes. As you can see here, equation 1, the PDF of the random variable x is defined as the derivative of the CDF of x. So basically, if we have a CDF, okay, and you want to find the PDF, all you have to do is just take the first derivative of the fx, or the distribution of the random variable with respect to x, okay, the first derivative. And that's basically what the PDF is all about, okay? So this is another distribution for the random variable. So you either have the PDF or you have the CDF, and you can find either one of them. If you have the one, you can find the other, as we can, if we have the CDF, you can find the PDF. And in a minute, we're going to see if you have the PDF, you also can find the CDF as well. The same with the, with the CDF, we also have some properties for this new distribution, the PDF. So the distribution, these are straightforward, يعني ما بدهم إشي. So the first property for the PDF fx, and by the way, the notation for the PDF, it's fx. Now we need to distinguish between this is capital F and this is small f. Okay, so some people, they use p, but p we reserve p for probability. Okay. So احنا هون راح نستعمل capital FX for F for CDF, and this small letter FX طبعا بتكون تالك بتكون ايش PDF. Okay. So the PDF, one of the first properties is it will have to be always larger or equal to 0, cannot be negative for all x. The next property is the area under the PDF will have to be equal to 1. So if you take the integration from minus infinity to infinity of the PDF, you will get 1. Okay, and the third property is if you have the PDF, you can find the fx or the CDF of x by taking the integration of the PDF from minus infinity to the random variable x, as you can see here. Okay. And then the fourth one, if you need to find the property of the random variable x, where x between x1 and x2, okay, you can find that by taking the integration of the PDF from x1 to x2. And if you go back to the CDF, the same probability here, we can find it by finding the fx for x2 and the fx for x1, and you take the difference between them. So you have fx2 minus fx1. Okay, so it will give you the same answer. So if you have the PDF, you can find it in this form, and if you have the CDF, you can find it the other form I just mentioned, fx of 2 minus fx of 1. Okay. Now the first two properties, اللي هم fx will have to be larger or equal to 0, and the area under the PDF is equal to 1. We use these two properties to verify whether a given function is a valid PDF or not. If you remember, we had to do the same thing for CDF. So if somebody will give you, let's say, a function, and you want to see if this is a valid CDF, we did that last lecture. You can go back to the notes and see. We had a couple examples on that, and we chose a couple of maybe about 3 properties. Okay, fx minus infinity, fx infinity, and fx will have to be continuous, at least CDF. In this case, the PDF, we want to show that this PDF is larger or equal to 0, and also the area under the PDF is 1. If this is the case, then the function is valid PDF. So let's take an example on that. As you can see here, the first example, part A, the PDF is given as an exponential minus x times the unit step of x. So is this a valid PDF? So like I said, we need to verify it's larger or equal to 0, and the area underneath this one is equal to 1. So definitely, since we have this function multiplied by unit step function, definitely will have to be positive. لأنه, if you remember, we mentioned that last time, and we had this one in signals and systems. The unit step function for less than x, for less than 0, when x is less than 0, it's going to be 0. So, and if x is 0 or larger, will be 1. So definitely will have to be non-negative function, as you can see here. Okay, so the first one is satisfied. The second one, بدنا ناخذ الانتجريشن for this function اللي هو PDF from minus infinity to infinity, and we all know how to do this. طبعا I did mention that to you, and you need to know, or at least to remember, how to do the integration differentiation for the exponential function, sine and cosine. These are the 3 basic functions. Okay. So the integration for this one can be written in this way if you want. Okay, يعني you can divide it in 2 parts, or you just take one of them and multiply by 2. Either way is fine. لأنه this is an even function. Infinity to 0, and from infinity. So when we do the math, we all know how to do this. It's going to be 1. So the first function, actually, it's equal to 1. The area under this function is 1, and it's non-negative, so it's really valid PDF. So this is a good PDF. So, and by the way, if anybody has any question, please stop me, ask me, okay? The second part, B, the PDF here, it's given as an exponential minus the absolute value of x. The absolute value of x. Well, let's find the distribution underneath it, the area underneath this function. So مثل طبعا هنا the absolute value of x, it's going to be negative x when x is less than 0, and positive x when x is larger than 0. So we can divide the integration in 2 parts: minus infinity to infinity, the exponential minus x, and this one, the other one, is minus x from 0 to infinity. Now, when we do the integration for the first part, it's going to be equal to 1, and the second part is equal to 1. معناته 1 plus 1 is equal to 2. Obviously, the area under this function is not equal to 1. Then it's not really a valid PDF. We didn't have to continue. We didn't have to show إنه مثلا larger or equal. لأنه if the area is not 1, معناته خلاص, it's not valid. We have another example here. Okay. Actually, you can continue these examples by yourself, but since this is a new distribution, let's go over it quickly. So this PDF, it's given, which is 3/4 times x squared minus 1 for the absolute value of x less than 2. Now, the absolute value, it's between x between -2 and 2, larger than -2 and 2. Okay. This is the absolute value of x less than 2. That's what it means, okay? Now, if we take a look at this function right here, the PDF, if we plug in any number between -1 and 1, not 1 or -1, anything less than 1 and larger than -1, it's going to be the value of the fx will be negative. If let's say if we plug in 0, okay? Obviously, it's going to be negative -3/4, of course, which means that the fx in this case is less than 0, which is it's not a valid PDF. So we don't have to continue, okay? Just as long as we show one point is negative, that's all we have to do. And finally, the last one, D, this is very straightforward. The PDF is 1, where x between 0 and 1 and 0 otherwise. Of course, when you take the integration of 1 from -infinity to infinity will be 1, and it's positive, so it's really valid PDF. This is very simple, okay? So this page it's what we did. We introduced the PDF and the properties of the PDF and how we validate a function, whether it's a PDF or not. This one شوية مغبشة بس okay. This is if you remember this this example, this is a coin tossing example. We keep repeating it. And the probability, we use it for the CDF, and now we're going to use it for the PDF. This is a discrete random variable, okay? If you remember last lecture, we said the fx of the coin tossing experiment was in this form, okay? We did toss the coin 2 times, I believe, or 3 times actually. And the outcome was 8 different outcomes, but they all have, you know, the same equal probability of happening. And we introduce a way, which is this example with this equation 2.5, how to write the fx in terms of the unit step function. Okay, so you can go back to the notes and the voice recording we did last time if you forgot that. So the fx was written in this way. The first one, the first point when x is equal 0 was 1/8 times u of x. The second one, 3/8 times u of x minus 1, shifted to the right, and the other one shifted to the right again by 1 point. And the third one, 1/8, shifted to the right again by 1 point. Now, we need to find the PDF. And on the last page, we said the PDF, basically, you take the first derivative of the CDF with respect to x. Now, if we go here, these are numbers. So all we have to do, we just want to take the first derivative of the unit step function, u of x. The derivative of the u of x with respect to x will give you a unit impulse function or delta function. Okay, so if we take one part of the, so if we take the distribution, the integration of this one is going to be 1 over impulse function. Okay, the second one is going to be 3/8 times the impulse function shifted by 1. The other one is 3/8 times the impulse function shifted by 2. And the third one is the same thing. So you will end up with this function right here. So if we have this function, all we have to do is take the first derivative of this one and you get back to, you will get equation 5 as shown here, okay? And this is the general form. If you wanna, you know, this is for the absolute values, okay? Now, if we have this function, and now we learn how to plot this one very easily, as shown in figure 2. This is an impulse, okay? So at 0 will be 1/8, at 1, 3/8, at 2, 3/8, at 3, 1/8, okay? These are the values right here. Now, طبعا CDF can cumulative. You begin with 1/8 and then half, you add these together and continue to until you reach 1, okay? So this is the, how, you know, when you have a discrete random variable, that's how you do it. You do it, just take the impulse function, for example, okay? Let's go to page 36, where we have a uniform random variable. This is a well-known uniform. Yeah, you've seen it before, probably in previous courses. And it's very simple. And the PDF for this uniform is basically 1/b minus a, where the distribution, or where the fx, or the random variable x, it's larger or equal to a, between a and b. And this is graph 3 is shown here on the right-hand side of the page. Okay. So anything less than b is 0, and larger than b is 0. Okay. So this is basically the PDF. And from there, we need to find the fx. Just like so if you have the PDF, you can find the CDF and vice versa. So if I need to find the fx, according to the properties we just learned, you just take the integration of the PDF from -infinity to x. So in here, we have 3 areas. We have x less than 0, x less than 1, and we have another portion from a to b. When x is less than a, and then x between a and b, and then when x is larger than b. So we integrate the first part. Definitely, this is the fx here is 0, as shown here. Okay. So the first part is 0 when x less than a. Now, when x between a and b, all we have to do, just take the integration of the PDF, straightforward, and the result is right here, x minus a divided b minus a. Now, for x larger than b, is equal 1. Why? Because according to the properties, okay, fx is always continuous on the right-hand side. So you begin at b if you plug in. So we said for x larger, when x between a and b. Now for x is equal b, this one's gonna be equal to 1, as shown here. Okay, which is valid. Okay, this is the maximum, is 1. Okay, now then it's going to continue. Anything larger than b, in this case, it will have to continue to be 1. It's not going to be going to 0. This is a CDF. So once you reach b, after b, everything will stay the same. It's going to continue to infinity. So basically, you can write the fx in this form as in equation 8. X less than a is equal 0. X between a and b is this, and then when x larger than b is equal 1. Now, if you take the first derivative of this one, you will end up with this equation as well, with the PDF, equation 7. Okay. Now we are on page 37. Again, this is we were given a PDF for 3 different parts of has 3 different parts. 0 when x is less than 7 but larger or equal to 13, and then we have a function x minus 3 divided by 25 when x larger or equal to 3 and 8. Okay. And x larger than 8 and 13. And so this is the fx or the PDF in equation 9. Now the question is, we need to find the probability that x has values greater than 4.5 but not greater than 6.7. So basically we go back to property number 4 actually, where we need to find x larger than 4.5 and less or equal to 6.7. And as we learned from the property, the first page we talked about today, all we have to do is take the integration between 4.5 and 6.7. طبعا if we take a look at the equation 9, the PDF, it will apply to the middle one, where x larger than 3 but h less than 8. And this will fall in between 3 and 8, 4.5, 6.7. This fx, x minus 3 divided by 25, and we do the integration for it. That's it. I mean, this is a simple example, but all we need to just kind of apply the property we just learned, okay? And we need to determine which one of these 3 parts we need to take from the PDF to do the integration. And obviously, after we do the integration, you see that the probability of this is equal to 22.88%. Finally, we have this example. We have random variable with a distribution or a CDF given in equation 11 on the same page, where the distribution here is 1 minus the exponential minus x squared divided by b times the unit step function x. Okay, so we're given the fx where b is larger than 0, it's constant. Okay, obviously it will have to be larger than 0, otherwise it will be infinite, so the whole thing will be 0. Now we need to find the PDF. So I mean, all the examples is just find CDF, find PDF, find CDF, find PDF. Okay, it's the same process. It's just to make sure we understand this process. So since we have the fx, all we have to do is take the first derivative. We can divide this one. We have 2 points. We take the unit step times the integration of the first part, and then we take the second part times the integration of the unit step. So the integration of the first part, it's going to be differentiation, not integration. Differentiation of the first part will be the u of x times 2x divided by b times the exponential minus x squared as shown in equation 12. Now the second part is مثل ما حكينا last 2 pages ago, I guess, the derivative of the unit step function is equal to the impulse function. Okay, and by the way, the impulse function, let's go back here and see what the impulse function is all about. Maybe okay, if you go back to page 35, I'm showing you here what the impulse function on equation 6. The impulse function is equal to 1 when x is equal to 0, for example, and is 0 when x is not equal to 0. So it's 1 at equal to, when x is equal to 0 and 0 otherwise. طبعا if there's a shift, like x minus x naught, فبتكون 1 at x equal x naught, صح؟ يعني زي خلينا نقول هنا it's going to be 1. 3 times 8 times 1، هنا الباقي بيكون ايش؟ 0. احنا بنحكي عن هذا لحاله. Okay, so if we go back here هلا اطلع هنا على this function right here. So the impulse function, when x is equal 0, this impulse function is 1, right? But when x is equal 0, this is going to be 1. 1 minus 1 will be 0. So this one is going to be 0. هلا if x is not equal to 1, when x is not equal to 0, this impulse function is 0. Therefore, the whole thing is going to be 0 all the time. لأنه anything other than 0, this impulse function will be 0. But at x is equal 0, the exponential will be equal to 1. 1 minus 1 is equal 0. So that's why the whole thing is 0, and the نتيجة هون بتكون بس the unit step times this. That's how we came up with this result. And this is the end of today's lecture. Any questions?
لا دكتور كله تمام.
Okay. All right. If you guys don't have any questions, مثل ما حكينا, what we covered today, احنا طبعا so far we covered chapter 1 and chapter 2 up to حكينا عن ال distribution اللي هو the main thing random variables CDF and PDF, and يعني we didn't cover much. Okay, so if you study the notes, we have 9 lectures. If you study the notes well and the examples, as you can see here, we have يعني wealth of examples لكل lecture. وبترجع للكتاب إذا بدك برضو في بعض examples. Understand the concept, understand the examples, the concept of يعني كل شيء, يعني مثلا the PDF, شو معنى PDF, كيف نتعامل معه, how we gonna show this is a valid PDF, okay, something like that. I think you will do well in the quiz. يعني الكويز هو مثل ما حكينا عليه 10 علامات مش كثير, بس طبعا المادة هاي برضو راح تكون بالميد وبالفاينل, فاحنا مش بس في الكويز, انت بدك انت prepare yourself for the mid and the final. So do it step by step. لا يعني لا تضيع ان تقول والله بس علي كويز, لا انت عليك هسه الميد كأنه مش عارف نزلوا الجدول, مش عارف جزء مطول شوية, بس هسه عندنا الكويز مثل ما حكينا يوم الأحد إن شاء الله. أنا وديت لكم إيميل وكلكم وصلكم الإيميل I believe إنه إن شاء الله الساعة 5 وراح يكون على الإي ليرنينج نفسه, رايح يعني على السكشن تبعكم. أوكي, بس تدخل ممكن يكون كويز, تدخل كالعادي يعني. أوكي, وفي didn't have any questions إن شاء الله. هلا سؤال, يوم الأحد أنا يعني كنت بدي أعطي محاضرة, فممكن إني أنزل النوتس للمحاضرة along with voice recording, بس إحنا ندسكس المحاضرة later on, يعني عشان نكون معكم وقت تدرسوا بدل ما يعني نعمل محاضرة يوم الكويز, ولا شو رأيكم؟
دكتور بيكون كويس والله.
طيب معناته إن شاء الله يوم الأحد مش ما فيش محاضرة, أنا بدي أحاول أنزل النوتس اللي راح ناخذهم ونخليهم, طبعا راح يكونوا قدامكم تدرسوهم بعد الكويز. وأول يوم من we meet like this we will discuss these notes, يعني لأنه إحنا أوكي يعني ماشيين أوكي, we not behind يعني بعدنا ماشيين أوكي بالمادة, فما في داعي نسرع ونكمل المادة قبل 3-4 أسابيع وإحنا معنا وقت. فبنزل المادة يا بنزلها قبل الكويز أو بعد الكويز, ما بنشوف. أول يوم من we meet we will discuss it.
طيب دكتور, بالنسبة
للكويز نعم,
بالنسبة للكويز حيكون ملتيبل يعني فاينل انسر؟
هو احتمال كبير يكون ملتيبل. اوكي, يعني فاينل انسر طبعا الملتيبل تشويس بيكون فاينل انسر. اوكي, هلا صراحة بعدني ما بديت به لأنه يوم الثلاثاء وبعد قدامنا يومين 3, فهو كويز ما بأخذ وقت كثير إن شاء الله, بس يعني فكر إنه يكون ملتيبل تشويس. ما بعرفش كم سؤال وقديش how long. طبعا أنا دائما بحدد الوقت based on the number of questions, فراح يكون إذا كان multiple choice بكون أسهل إنه وإلكم, يعني لأنه بالحالة هاي بدال ما مثل ما تقول نعطيك سؤال ومثلا ارفعوا ما ترفعوش, يعني بتكون هذا, بس احتمال كبير يكون multiple choice, بس بتكون انت جاهز ل يعني اي طريقة ثانية. هو doesn't matter اذا انت مثلا خلينا نقول اجاك سؤال انه والله verify this PDF انه valid PDF ولا لا, بدك تحله صح ولا لا. فطبعا راح يكون اذا كان multiple choice بده يكون الجواب yes or no مثلا, او ممكن بدك تلاقي الاريا او كذا, يعني بعرفش. مثل ما حلينا سؤال مثل هيك, مثلا بدي اوجد البروبابيلتي from this to this. اوكي, فمعناته البروبابيلتي مثلا 22.88 ممكن 25 ممكن 26 معناته بدك ايش توجد الجواب. ما انتم عارفين شو المالتيبل تشويس ليش بشرح لك اوكي بس يعني احتمال انه يكون ايش multiple choice. Okay. Any other questions? Okay. If you don't have any questions معناته good luck. ان شاء الله نشوفكم يوم الأحد الساعة 5 p.m. وباي ذا واي الكويز ما في ميك اب ف يعني احكوا لزملائكم واذا في بعرفش انا شرحت من اول بس الزملاء المش حاضرين انه واحد يقول والله بدي اعمل ميك اب ما في هذا كويز اوكي وحتى لو كان في ميك اب يعني مثلا ميد تيرم ممكن يعملوا ميك اب احتمال يكون الميك اب يكون بالجامعه هذا اذا يعني للميك اب للميد تيرم مش للكويز فدائما الميك اب بيكون شغله اكثر مش لانه دائما الطلاب باخذوها انها عقاب هي مش عقاب هي انه انت اخذت وقت اكثر من زملائك فاحنا بنحاول انه ايش يعني to be somewhat fair اوكي طبعا الطلاب ما بصدقوش الحكي هذا انت حاول انه يعني ما تتاخرش على الميد تيرم الا اذا لا سمح الله الواحد صار معه ظرف يعني بس again بالنسبه للكويز ما في ميك اب لانه just a quiz اوكي any questions اوكي تفضل في كان زينب بدها تحكي
لا دكتور
اوكي اذا ما في عندكم اي اسئله معناته ان شاء الله بنشوفكم يوم الاحد الساعه 5 او انا طبعا مش شرط اكون يعني بتكون افيلبل يعني على المنصه الاي ليرنينج مثل ما حكينا يلا يعطيكم العافيه
يعطيك العافيه
اهلا باي